Okay, question number 2. We have these flower beds, so we have a garden. The garden is 6 metres across, therefore this point here is at 6, 0. That's at 6, 0. And it's 4 metres high, so that's 0 and 4, 0 and 4, 6 and 4, 6 and 4, and D is at 6 and E. Okay, so we have this rule which determines the division between the flowers and the grass, and it's k root x. So I'm going to take k root x and define it. And I'll call it f of x. There it is. So there's my f of x. What would be the value of k if it goes through this point here? Therefore, f of 6 equals E. So f of 6 equals E, and I solve for k. And there it is E6, so root 6E on 6. If it went through point E, therefore E of 6 equals 4. And it equals 2 root 6 on 3. Next, I want the area to equal 8. So 8 equals the integral area of grass. So this is grass. So the integral from 0 to 6 of g of x dx, and then solve for k. So if I take f of x, and I take the integral from 0 to 6 dx, and that answer I make equal to 8, and I solve for k, all in one go. And k should equal root 6 on 3. Okay, in a second design, I separate the flowers in the garden with a 0.7 metre wide path. So h of x will be g of x plus 0.7. Write a definite integral that represents the area of the path. Well, top curve minus bottom curve, so it's going to be the integral from 0 to 6 of h of x minus g of x. And since h of x is g of x plus 0.7 dx, or I could write the integral from 0 to 6 of 0.7 dx. And what will be the area of the path? It's going to be the same as a rectangle 6 by 0.7 that's been stretched up, but it's still always a vertical distance up here of 0.7. So it's going to be 4.2 or 21 on 5. But just to double check that, if I take this and I do 0.7 dx, that gives me 21 on 5. Units squared, units squared.